series on vamsivisions, and thank you to all my subscribers and viewers for your love and support. I appreciate each and every single one of you. I'm posting this midweek episode so I appreciate all our participants who have taken effort during the school holidays. I recently got some understanding on arc bridges after completing dome and arc bridges, the STEM episode. I'll leave a link to that video in the description box down below for those of you that haven't seen it. But I don't really know about other types of bridges, so that's why I'm excited to learn more about suspension bridges over the course of this video. I hope you learn along with me. Before moving on to that, I'm excited to reintroduce our participant Sagar to you all. He always challenges himself to do harder STEM projects. Today he'll be showing us how to build a suspension bridge using drinking straws and string, and he will also explain how it works. Come, let's watch him make the suspension bridge model. Over to you, Sagar.
We know that bridges are built to facilitate road and rail transport across rivers and other water bodies. But do you also know that there are different types of bridges? For example, the London Bridge is a box section bridge, while the Tower Bridge is a bascule bridge. On the other hand, huge bridges like Brooklyn and Golden Gate are suspension bridges. Engineers build suspension bridges with concrete and steel cables. The concrete tower will support the steel cables, and the steel cables will support the road, which carries hundreds of cars and trucks. My name is Sagar, and today we are going to make a model of a suspension bridge using paper straws for concrete and string for cables. Take 15 straws and make it a bundle. Hold it tightly and put tape on the top and bottom. Then you make one tower and make 4 of these. Like these. Take a toothpaste box, make 2 holes, insert the towers in and make 2 of these. Now the 2 holders are ready. I have added pebbles inside the toothpaste box to make it firm. Take 2 lorry sticks and stick them on top of the tower. Like this. Take a straw and cut it into 4 pieces, each 1 inch, and stick it on top of the lorry stick at 90 degrees. This will hold the cable. Make 2 square cardboards and stick them firmly under the structures. I have made a road out of cardboard which is approximately 1 meter. Now, if I add these 2 cars, it starts to sag. To prevent this from happening, we have to attach the strings to the road. I have punched holes in the edge of the roads, each 10 centimeters apart. I have taken a 5 feet long string and inserted inside the straws to each of these structures. Then I have taken smaller strings and attached the main cable and the road. Now, if I place this car on the road, it is not sagging anymore because the strings are holding it up tight. Earlier, the road sagged under the weight of the cars because it was not supported. The real bridge would break apart under a heavy load. The bridge must be able to push upwards to support the load. This upward push is enabled by the vertical cables. These are further supported by the main cables. The main cables are supported by the tower, which in turn is supported by the ground. Thank you for watching.
I loved watching your demo, Sagar. It was so realistic. Also, you painted and decorated it so well. Thank you so much, Sagar, for sharing us your detailed explanation and your lovely introduction with us all. We would love to see more from you in the future. Don't miss out on the Test and Tweaks section, which is coming up next. After watching Sarkit's video, I too wanted to make a suspension bridge but with polydrawn pieces. Here is the suspension bridge model that I made. As you can see, I've used square and triangle pieces to make the bridge structure. I used these plinths to make a strong base and this string to support the road. Look at this, I've placed 8 miniature heavy cars onto this bridge and it's still standing strong and sturdy. Let me explain the science behind it. I have drawn this picture to explain the science behind it. The main cable pulls down on the tower. The vertical cables pull down on the main cable. The roadway is pulled up by the tension in the vertical cables, and the weight of the whole bridge pushes down on the towers, but the ground supports them. If you put objects on your bridge when it isn't supported by cables, the load will make the road sag. A real bridge without cables would break apart under the heavy load. The bridge must be able to push upward on the load to support it. This upward force is supplied by the tension in the vertical strings, and it is supported at the top by tension in the main cables. The main cables are supported by the towers, which are themselves supported by the ground. The Golden Gate Bridge is an example of real-world engineering, and the cable-supported roof is an example of real-world technology. Perhaps the best known suspension bridge in the world is the Golden Gate Bridge just north of San Francisco, USA. Around 112,000 vehicles cross this bridge every day. The suspended roadway is 2.7 kilometers or 1 1/5 miles long and is held high above the sea by two main cables measuring 2.3 kilometers or 1 2/5 miles long. BC Place Sports Stadium in Vancouver, Canada has a fabric roof held up by 35 kilometers or 22 miles of steel cables. The cables are supported by 36 steel towers, which do the same job as the towers in a suspension bridge. The fabric roof is strong enough to support 7,000 tons of snow and can retract to create an open-air stadium when the weather is good. Sarkit referred to Robert Winston's Science Lab book for making his model. Now I've gained a good understanding of suspension bridges and its structure. My wishes to Sarkit for putting a lot of effort in doing this. I appreciate your interest. Also, I extend my thanks to Satya. I hope you all enjoyed watching this video. Also, I recommend you to watch my earlier STEM videos, which I will leave a link to in the description box down below. Like Sarkit, you can also participate in the STEM learning series by sharing a video for me to post on this channel. Please drop a like on this video and press that subscribe button. I'll see you all in another STEM video next week, and until then, bye!